the sum of the interior angles. Where have you ever heard the word interior before? Think about it. Have you ever heard of it? Well, in math, when we talk about interior, we're talking about interior angles of a polygon. They're the angles that are the inside. In this quadrilateral, you can see that there are 4 angles inside of it. Now, if you took a triangle and you tore off the 3 corners off, then what do not have to be in the large pieces? So if I take off the 3 corners off, they do not have to be large. They just have to be pieces from the edges of the triangle. And if I put them all together, what they're going to make is what is a straight line. They are going to make a supplementary angle. It will form a straight line putting all 3 of those corners together. Therefore, when we say out a triangle, we can say that the sum of the interior angles of a triangle are 180 degrees. So let's look at this triangle and measure these angles and see if we really come up with 180 degrees. Remember, to line up our protractor, we have to get it right on the vertex. Line up where the vertex is. Get your reference line all lined up. I'm going to start with angle A. This is angle A, and I'm going to measure where do I think angle A lies. I'm going to go all the way around. Mine's a little bit more difficult than yours, but I'm about, let's say, 120 degrees. So angle A is going to be 120 degrees. Then I want to take it off and go ahead and do angle B. So reset my protractor. Since mine is on here, I need to reset it each time and decide how am I going to measure now angle B. Well, again, I'm going to set it right on the vertice, line up my reference angle, and try to determine how much angle B is going to be. Well, it looks like angle B is right around 24 degrees. Looks like it's 24 degrees. Now it's time to measure angle C. Now, in order to measure angle C, I'm going to have to turn this protractor around a little bit so that I can get it right on the angle. Remember, I have to line up with the vertice and line up the angle exactly. So you may have to turn your book, turn your protractor, whatever you have to do to get it to line up exactly where you need it to be so that you're right on the vertice. Now, again, mine's a little more difficult than yours because of trying to do it on the screen and having to have all the parts line up exactly. But when you have it on paper, it's a little bit easier to do, but I'm trying to do the best I can here for you. So again, I'm going to pull out my number and I'm going to see where exactly does angle C lie. Well, this case, I gotta go this direction, so I'm about at, it looks like right around 38 degrees. Make sure I'm lined up exact here. Maybe 37, 36, somewhere in there is where I'm at. So if I write down 36, let's just say, I'm going to go on the smaller side here, 36 degrees. Then I need to add them up because I know that the sum should be 180 degrees. Well, do I get 180 degrees when I line them all up? Well, 120 plus 24 plus 36 gives me exactly 180 degrees. So I know that all my angles are approximately correct because I equaled the 180 degrees. Now, there are many more in here for you to practice measuring. I'm not going to measure them all out, but you can go ahead and stop the video, measure them out, check with me in class, and see how you did. We're going to talk about how can we find the measurements of these interior angles without a protractor. Now, when you look at the 2 figures below, you can say, how am I going to find the sum of all of these angles? Well, we could predict what we think they're going to equal, or we could possibly come up with a rule of how we want to do this. For me, when I want to find out the sum of the interior angles, it doesn't matter if it's a concave or a convex angle, I would do the same process. I would cut them into triangles. And I would start at one vertice. In order to cut in triangles, you have to start at one vertice and always start at that same vertice. And so if I start at 1 and I want to make triangles, well, I can't go next door to the one right next to it, because if I went to the vertice right next to it, that's just making a line. That's not helping me with my triangles. So that's not going to work. So if I wanted to go ahead and start at one vertice, go to another vertice to find triangles, you can see here I've made 2 triangles. I know each triangle has to be 180 degrees, so 2 times 180 gives me 360 degrees. So the sum of the interior angles for that figure would be 360 degrees. Now here's another one. Again, start at one vertice. Go to every other vertice that is not the next door neighbor. So go to this one, I can go here, and I can go here. Noticing I always started at the same vertice. My lines aren't coming out real great, but you can see what I'm trying to do. And then write down how many triangles did you get. You had 1, 2, 3, 4. 180 times 4 would give me how much? Well, 720 degrees. So I know that the sum of the interior angles of that polygon is going to be 720 degrees. Let's go ahead and look at this cartoon. By now you've probably concluded that the sum of the angles measured in a polygon depends on the number of angles or the number of sides. You may have also discovered a rule for predicting this angle sum of any polygon when you know the number of angles. Here is somebody looking at it, Hannah and Joel, wondering whether they could use what they know about the angle sum of triangles to think about the angle sum of other polygons. I can divide any quadrilateral into 2 triangles by drawing a diagonal line. That means that the angle sum of each triangle is 180 degrees, so the angle sum for the quadrilateral must be twice that. That means that every quadrilateral must have an angle sum of 360 degrees. Wondering if that works for all polygons. Well, here's 2 pentagons. We want to divide these up into triangles to determine how many triangles we have to find the sum of the interior angles. Remember, you start at one vertice. You go to every vertice besides the ones that are next door. And you must go from the same vertice every single time. Otherwise, you're not going to get the correct number of triangles. So in this case, I can divide this pentagon up into 3 triangles. So the sum of the interior angles would be 180 times 3, which would give me 540 degrees. Here's another pentagon. This one's concave. It doesn't matter. Pick one vertice. I normally pick one that's kind of in the concave part, just so I can reach every other triangle easily. Here's go to this vertice, go out to this vertice. Again, I have 3 triangles. That means the sum of those angles need to add up to 540 degrees. How about a hexagon? Same process. Start at one vertice. Remember, you're never going to go to the next door vertice or the one right next to it. You're always going out across, and you're starting at the same vertice every time and going to every other one. How many triangles was I able to create? I was able to create 4. Again, multiplying 180 times 4 is going to give me 720 degrees. So the sum of those interior angles must be 720 degrees. Remember a concave one, you do the same thing. Start at one vertice. I always start at the part that's concave, just so I can reach all the other vertices. And here we go. We'll go out to this one, up here, over here. Remember, we do not go to the one right next to it. It only makes a line. And again, I have 4 triangles I've created. 4 triangles have the sum of the interior angle at 720 degrees. Triangles are all 180 degrees. That's what they all equal. No matter what kind of triangle you have, it'll equal 180 degrees. Quadrilaterals, again, start at one vertice. I'm going to start at the smiley faces and go to all the other vertices that I can that are not right next to them. And I'll see that each one of these gave me 2 triangles. How about a pentagon? Again, start at one vertice. I'm going to start with the smiley faces, going to every other vertice that is not right next door to it. That way I can reach all the vertices and see how many triangles each one of these were able to give me. Again, there's 3 triangles. It doesn't matter if they're equilateral triangles, scaling triangles, or isosceles triangles. There are 3 triangles, and the interior angles are going to be the same. You're going to take 180 times 3 to find the sum of the anterior angles for this pentagon is going to be 540 degrees. Whether it's a hexagon, you would do the same process. And even with a 13agon, I'm going to do one of them for you. Starting at the smiley face, I'm going to go out to every other vertice that I have that is not right next to the one I started with. Noticing that I'm always going back to the smiley face to start, and then count how many triangles was I able to create with a 13agon. That's just a figure that has 13 sides to it. And it looks like I have come up with 10, oops, I missed one, 11 triangles there. So that means I would have 11 triangles. Suppose you had a quadrilateral that has 90-degree angles. What is the measurement of the 4th angle? Well, think of this. You have a quadrilateral, 4 sides. 3 of the angles are 90 degrees. Remember, I can show them by the square. What does the 4th one have to be? Well, we know that a quadrilateral can be broken into 2 triangles. That means that the sum of the angles must equal 360 degrees. Well, if I have 3 of the triangles at 90 degrees, that gives me 270 degrees. That means I would have to add in another 90 to get to that 360 degrees. So the angle that's missing must also measure 90 degrees. And the way we know that is because it is a quadrilateral. And so they have to add up to 360. The 2 quadrilaterals that would actually do that would be the square and the rectangle. Now, think about an 8-sided polygon. How would we do that as well? Well, it's the same thing. We don't want to draw, but we want to predict how many triangles do you think we would have? Well, if we were to predict out and we kind of look at our patterns we have, the number of triangles we would have would be, not 7, it would be 6 triangles that we would have. And if I drew out an octagon, I'm not the best drawer, but I will do the best I can here. I would draw an 8-sided figure because that's what an octagon is. And then I would go from one vertex and connect to all the rest of them that I have. Sometimes it's a little hard to draw, especially when you have large figures, so take your time. And I would count. I have 1, 2, 3, 4, 5, and 6 of them. That would give me 6 triangles. The sum of the interior angles would be 180 times 6. To determine I would have 1,080 degrees. Now we can do same thing for a 15agon. In a 15agon, I'm going to have a 13-sided, I'm going to have 13 triangles for a 15-sided figure, and the sum of those angles would be 2,340 degrees. Now, how am I starting to figure this out? Well, did we see any type of pattern there? How do we find the number of triangles of the polygons? Well, if you were paying attention, the number of triangles is 2 less than the number of sides that the figure has, or any of the polygons. And then you would have to multiply the number of triangles by 180 degrees to find the sum of the interior angles. Let's make a chart to try to figure this out and see what we can see. A triangle, the number of triangles it has is 1, so the sum of the interior angles is 180 degrees. A quadrilateral has 4 sides and can be broken into 2 triangles for a sum of 360 degrees. A pentagon has 5 sides, and I can break that pentagon into how many triangles? 3 for 540 degrees. Are you seeing a pattern yet? A 6-sided figure would have 4 triangles for a sum of 720 degrees. A heptagon is a 7-sided figure, which would have 5 triangles for a sum of 900 degrees. An octagon has 8 sides, which would make 6 triangles for a sum of 1080 degrees. A nonagon has 9 sides, which can make 7 triangles for a sum of 1260 degrees. Now, a decagon has 10 sides, which you could make into 8 triangles for a sum of 1440 degrees. Now, an n-sided figure. Well, an n-sided figure, we don't know, would have n number of sides, but how would I figure out how many triangles that would be? Remember, n minus 2. Our pattern is we have 2 less triangles than the number of sides. So if I wanted to find out the value, I would have to say that's n minus 2 times 180 to figure out what it would be. Now, using that, what I know about n minus 2, where n is the number of sides times 180, I could find the value of an 11-sided figure and a 15-sided figure. For 11, I would take 11 minus 2 times that 180. Well, 11 minus 2 is 8 times 180 to find out that it's 1620 degrees. I can use that to help with a 15-sided figure. 15 minus 2, don't forget those parentheses so that we're sure that we're doing that first. And then multiply it by 180 degrees. So this would be 13 times 180 to get to 2340 degrees. So to find the sum of the interior angles of any figure, you could break it into triangles. We can also note that the number of triangles we're going to have is 2 less than the number of sides of the figure. So there is a formula for that. The formula for finding the sum of the interior angles is exactly what we just did. It's n, the number of sides, minus 2, all times 180 degrees. That would be the same as cutting things into triangles to determine what it would be, or just using the formula. The key is to count the number of sides. I like to put dash marks on my sides so I don't miss any. So in number 1 here, I have 1, 2, 3, 4, 5 sides. So 5 minus 2 times 180 degrees, don't forget my parentheses, so I'm sure to do that first, would be 3 times 180, which equals 540 degrees. So the sum of this angles would be 540 degrees. Now, number 4 has 1, 2, 3, 4 sides. Well, that would be 4 minus 2 times 180, which would give me 360 degrees. You try the next 2, pause and come back and see what you get. Okay, for number 7, I hope you found out that it had 1, 2, 3, 4, 5 sides, just like we had before, and it's 540 degrees. And 10 is just a triangle, so it is 180 degrees. Because a triangle has 3 sides, and if I took 3 minus 2 and multiplied that by 180, that's just 1 times 180 for me. Here are some more for you to practice on. Go ahead and pause the video now and practice and see what you do. Welcome back. How did we do? Well, number 2 has 1, 2, 3, 4, 5 sides. That means the sum of the interior angles would be 540 degrees. Number 5, I hope you got 360 degrees. 8, 1440 degrees. 11, 360 degrees. 3, 1080 degrees. 6, 1260 degrees. 9, 540 degrees. And 12, 1800 degrees. Remember, be careful counting the sides that you do not miss any. Now, knowing what we know about that, we can find the sum of the interior angles. When we know how much that they need to add up to, we can always find the missing one as well. So in this figure, we have a 5-sided figure, so the sum of the interior angles must be 540 degrees. Well, what I need to do is add up what I already have in here. So one angle is 105. I have one that's 118, one that's 75, and one that's 130. So I'm going to go ahead and add these all up Go ahead. You can use your calculator with it. I'm just going to go ahead and add mine out here and find that I got 528 degrees. So I'm going to take 540 and subtract my 428 degrees to see what else I would need. And it found that the missing angle must be 112 degrees. So by adding up everything I have and knowing what the total would be, I can go ahead and find what is that missing angle. Try number 2. Come back in a minute and check. Be sure to count your sides to know what the sum has to be to start with. Well, I hope you found that the sum needed to be 900 degrees and that the missing angle was 112 degrees. We have a lot more here to practice. You can go ahead and practice and check with me in class to see how you did. Last thing I want to look at is when there's triangles. Triangles are no different. The sum of the angles have to add up to 180 degrees. So if I look at the first one I have here, I can see that by looking at what I have a 51 degree angle and a 40 degree angle. If I add them up, I get 91 degrees. So I would take 180 and subtract that 91 that I have to find out that the missing angle needs to be 89 degrees. Now, if you look at number 3, well, it only gave me one angle. How am I going to find the other one? These dash marks right here mean that these sides are congruent. They are the same. Remember, congruent means equal. If sides of a triangle are equal, that means the angles opposite them are equal. So that means this angle is opposite is 45 degrees. This angle is opposite this way. So D would also be 45 degrees. And then now I have 2, I could find out that C was 90 degrees. All right, that's the process that we're doing for today. We have a lot more practice in our book for you to go ahead and practice on. And now you can go ahead and finish your homework on page 6.